Hello there. So we're trying to show you how generative AI can be used to generate system builder assertions, and those generated assertions you could run through SVALint, an open source system Verilog assertion linter. So we're going to use two technologies. One is, in my case, I'm using ChatGPT. You could, of course, use your own favorite LLM for it. But let's start with something. So I said, let's go to system ChatGPT. Once you have your account, you log in. And here's my prompt. I said, okay, I want assertion for two 5-4 properties first inverse first out, and it generated some code. I'm just going to navigate all the way down and say, okay, here is my code. So it says module S54 SVA, there's clock, reset, push, pop, full, empty, and then there are two properties that it generated for me. Full means empty should be 0. And in case of full, and if there is another push at the same time, one clock later, push on full error, which is an output from the DAT, should be asserted. So the assertion looks clean and generated by ChatGPT in a matter of seconds. So let's see what's wrong with it, if you will. Of course, you could manually review it being a small code, but let's use a more professional system Verilog assertion linter. So I go to this EDA Studio. This is the URL is studio.hpcinfra.com, and you should create your own account so that you can run one without any login as well. But if you want to run more, you should. I highly encourage. It's a free account that you should create. And once you log in, and I have already copied pasted that same code here, but you see that there are some pull down menus here at the top. You see that there is Verilog HTL as well as system Verilog. For the sake of it, I'm going to use system Verilog because that's what we are doing. But even in Verilog, you would see that there is Icarus Verilog, an open source simulator, as well as SVALint and uses a popular open source synthesis platform. So let's go to system Verilog. In system Verilog, you would see SVALint, SVECK, which is a system Verilog class-based linter for again, system Verilog test benches. And then EBMC is an open source formal verification tool, and then this uses. Now, back to what we did, we copied pasted that code over here in the test bench, and the design I just left it, what was there, and I go and say run. And once I run, you'll see the magic. I'm going to show you that it actually says running simulation. Of course, it's now running linting. Under the hood, what it does is it does actually a parsing of the code. I'm using a compiler or a parser. It's also open source. And once it does, it goes and runs a linter, which is developed by my team at AsFigo. And you'll see that, okay, let me pull this down. You'll see that now quickly, the output from it. So the results from SVALint on the linting the design, since there were no assertions, we wouldn't really find much. But the number of rules executed is 13, and then there are no warnings or errors. Quite expected. And by the way, we use a similar style such as in UVM. And now in case of test bench, you see that it actually produced a lot of output. Let's go and check what is really relevant for us. So it gives you the summary, which is very similar to a UVM report summary for most of you who are familiar with UVM. So we follow a similar principle in terms of reporting. And you see that the number of rules executed is 13. And then it tells you what errors and warnings are. And let's go and check one of them, which is, let's say, functional missing fail action block. So if you notice, there are these assertions, but without any fail action block. And in a real world, this is considered a very bad practice because you want to have, let's say, UVM error whenever an assertion fails so that you can control it, you can stop your simulation, you can start your debug, etc., etc. So let's go and add that right here and then recompile. And I want to show you that it is really, really fast to do this SVALint. And all this is happening on the fly on the web. You do not have to install anything thanks to EDA Studio from HPC Infra. So you see that you could actually do system Verilog assertion linting on professional code for free. And the whole thing is done through ChatGPT now for us. So essentially, ChatGPT can give you some basic code, but if you want to get a professional code, you need something like SVALint, and this is brought to you for free with EDA Studio. Right now, with that, let's go and add an assert fail action block, else begin, then end. Most of you know the syntax, so I'm not going to explain the syntax. Right. Unfortunately, the system, the ChatGPT didn't give you exactly what you wanted. I mean, it gave you something, but it is not ideal. So I'm going to add a simple error message, but of course you should do a lot more. Empty is high when full is asserted. Right. So I'm going to just show you that it's actually quite possible to do this very, very fast. Instead of fixing all errors, of course, your goal and your challenge would be to fix all errors, right, from the SVALint. But just to give you the platform as an example, I'm going to show you that actually I created this. I fixed at least one error for the fail action block. And you see that the total number of errors were 8. Now let's rerun it. And you'd also see how it automatically saves the code on the cloud. And again, it runs the simulation. And you'd find the simulation results, I mean the SVL results from SVALint. Again, no surprises on the design side, but let's now look at the verification of the test bench code. In the test bench lint, as before, the number of rules is 13, and you see the number of errors have gone down to 7. And you would also see that functional missing fail action block has reduced from 2 to 1. So that, and your goal in your own design, or the one that you're going to create using ChatGPT or any other generative AI LLM, is to get to 0 errors and 0 warnings. Yeah. And of course, there are many other features in this particular studio. Feel free to explore and then join our Discord forum to understand more if you want. I'll see you later. Thank you. Have a good day.